Here is a sample problem on momentum and impulse. This is taken from the practice worksheet. A steel ball strikes a massive wall at an angle with the plane of the wall. It bounces off the wall with the same speed and angle as shown in the figure below. Which vector indicates the direction of the net change in the momentum of the steel ball? So we need to solve for the direction of the change in the momentum of the steel ball. Now take note that the question could also ask which vector indicates the impulse. So remember that impulse is just equal to the change in momentum. Now, considering that the change in momentum is actually equal to mass times the change in the velocity, so the direction of the impulse or the direction of the change in momentum is actually just defined by the direction in the change in velocity. Remember, the change in velocity is velocity final minus velocity initial. So according to our illustration, this is the direction of our velocity final and this is the direction of our velocity initial. So let us write that down. The direction of the final velocity is this. On the other hand, the direction of the initial velocity is that. Now, let's go back to the definition of our change in velocity. Change in velocity is Vf minus Vi. I could actually rewrite this as Vf plus negative Vi. You will understand later on why I have written Vf minus Vi in this way. But nonetheless, so Vf plus negative Vi is equal to Vf minus Vi, and therefore negative Vi is just actually a vector that is in the opposite direction as that of Vi. So I could rewrite it or draw it this way. This is our negative Vi. Now recall that in addition of vectors, we would actually be able to use the head to tail method. So head to tail. The head of the first vector connected to the tail of the second vector. So having said that, Vf plus negative Vi could actually be drawn this way. The head of the first vector, so our first vector is Vf. This is our Vf. Let me just draw that then. So that's our Vf. The head of the first vector would be connected to the tail of the second vector. So our second vector is the negative Vi. This is our second vector. So I would connect the tail of the second vector to the head of the first vector. This is my first vector. This is the tail of the second vector. So I will draw this way. So this is my Vf and this is my negative Vi. Now to determine the change in this vector, we just have to connect the head and the tail of the first vector to the head of the second vector. So as a matter of fact, this is going to be the direction of our delta V. So the tail of the first vector to the head of the second vector. This is the head to tail method. So having said that, the direction of the change in the momentum of the ball, would be related to the direction of the change of velocity. And therefore the correct answer is C. So as a recap, the first thing that you need to do is to rewrite change in velocity. Instead of Vf minus Vi, we will have Vf plus negative Vi, and that means we would flip the direction of our Vi. And then using head to tail method, wherein the head of the first vector is connected to the tail of the second vector, we will be able to determine the direction and the change in the velocity by connecting the head, the tail of the first vector to the head of the second vector.